This is the BGP lab for IPv6. Let's go to action item number 1. Customer A has 2 offices running IPv6. It will use the same autonomous system number at both sites, use multi-protocol BGP, and provide connectivity using your autonomous system number 65,000 as a transit autonomous system. OSPF version 3 has been deployed within autonomous system 65,000, so routers 2, 3, and 4 are aware of the loopbacks addressing. So we have this customer that has this office and this other office. He's willing to use the same autonomous system at both sites, and it will need to communicate this network, the network 2000/24, with network 2001/24. So we will need to use our autonomous system as a transit autonomous system, and we already have OSPF version 3 here, so these loops are known. We'll have to establish eBGP here, and iBGP between the internal routers in this autonomous system. So let's do that. Okay, let's go to router 1 and configure BGP. Router BGP 65.001. We have to issue here router ID, because remember that this is a pure IPv6 network, so we don't have IPv4 IP addresses in any interface at all, so the operating systems cannot provide you with a router ID automatically, so we have to enter it manually. So my first neighbor will be router 2 that has this IP address and belongs to this autonomous system. And we'll go to address family IPv6, and we'll have to activate it. And we'll have to advertise our network 2000/64. So let's go to router 2 and configure BGP. Notice that we are only running OSPF version 3, so nothing else. Router BGP 65,000, BGP router ID 2. Neighbor will be router 1, 001, and the remote autonomous systems will be this one. And I'm going to establish the neighboring with router 3. I want to become also neighbor with router 3. This will be an iBGP session with router 3. I will use loopbacks. Remember that for iBGP, the recommended way to configure the peering is with using loopbacks. And I want my loopback to be the source IP address for my packets with the router 3, for the neighboring with router 3. So I use this command. I don't use this command for eBGP because they will using the one IP addresses, and they are connected back to back. So no loopback for eBGP. So let's go to address family IPv6 and activate my eBGP neighbor and my iBGP neighbor. Okay, let's go to router 3 and do the same. BGP router ID 3323. Neighbor, router 3 will only have iBGP peers, and this will be the peering with router 2. And this will appear with router 4. And I'm going to use my loopback with each of them, and let's go to address family IPv6 and activate them. Activate. Let's go to router 4. Router 4 will have one IPGP session and one eBGP session. So it will be neighbor with router 3. How do they know they will have an IPGP or an eBGP session using the remote AS? If there's remote AS is the same as my own autonomous system, this means that this session will be an IPGP session. But if the remote AS is different than my own autonomous system number, that will be an eBGP session. So let's go to address family, IPv6, and I will have to activate both to activate IPv6 with this neighbor. Okay, so let's go to router 5, do the same. Notice that we are not running IPv6 protocols. It will be our only protocol, 61 BGP router ID 55555 neighbor 2010 00455 remote AS. This will be I'm sorry, this is the IP address of the other site. Okay, address family IPv6. I will have to activate this neighbor, and I will have to advertise my own network, which is the 2001/64. So let's troubleshoot this. Let's see if I have something in my routing table. I have no BGP coming from router 1, so something is wrong. Let's go to router 2 and see what's going on with my prefixes. Show IPv6, show BGP, IPv6 unicast neighbor. First, I want you to see this. Notice that when a BGP neighborship comes up, the capabilities of both networks are exchanged. So in this case, the iBGP session shows that the address family IPv6 unicast capability has been advertised and received. So that is a good thing because they can work with IPv6. The same thing with the eBGP session with router 1. With router 1, the capabilities exchange are IPv6 unicast advertised and received. So let's issue this other command to see how many prefixes are being received. I am receiving one prefix from router 1, but I am not receiving any prefix from router 3. So let's issue this command here. Router 3 is receiving one prefix from router 2 and one prefix from router 4, but router 3 is not sending these prefixes to other IBGP neighbors. That is a law of IBGP. If you receive a prefix from an IBGP neighbor, you shall not advertise that same prefix to another IBGP neighbor. This prevents loops within IBGP networks. So we have to break this rule. So we'll have to configure. We have two options here. I can create an IBGP session between router 2 and 4, which means I will be doing a full mesh of IBGP sessions here. Or option number 2, I will configure router 3 as a route reflector. The route reflector breaks the IBGP rule of not advertising IBGP prefixes. So let's go to router 3 and make it a route reflector. So for the neighbor, for neighbor 2, this will be my route reflector client. And for router 4, this will also be my route reflector client. So router 3 becomes a route reflector, and now router 2 that was not receiving prefixes from router 3 should start receiving prefixes. So router 3 in this network has become the route reflector. So let's see if router 1 is receiving prefixes from router 2, because we have to fix another thing. Okay, let's see. It is. It seems that it is not receiving prefixes. It seems, but let's see another command that will give me a little bit more information. So it is actually not showing up receiving anything. But if you see something here, it is denying some prefixes, in this case because it is detecting an ASPAT loop. So it has detected two prefixes that are unacceptable because of the ASPAT loop rule. This applies only for eBGP sessions. So it is actually receiving prefixes from router 2, but it is denying them due to this rule. And this rule says that if a prefix comes from an autonomous system that if a prefix includes, I'm sorry, if a prefix includes in its attribute ASPAT an autonomous system that is the same as yours, you will have to drop that prefix because this means that there is some kind of loop in the network. But we know for sure that there is no loop here because this office is not connected to this office by any other means. So we are going to break the eBGP rule here, and because we want that prefixes that have traveled through this autonomous system 65001 be able to land into the same autonomous system. So we are breaking the eBGP rule here. So how do we do that? So if I remember correctly, I will have to go here and for my neighbor, I will have to enter this command, allow us in. So I can permit that the repetition of my own autonomous system within the advertising can happen maybe 2 times, could be. And let's clear my session, clear BGP with this soft. Now let's see. I am now receiving one prefix because I entered the command allow us in. I break the rule of the anti-loop prevention, and now I should have this BGP route landing So let's going to do that here because it probably has the same problem. Show IPv6, show BGP, IPv6 unicast neighbors. It is also denying the prefix from landing in our routing table because it is applying the same rule. So let's disable that rule. Let's clear the session. Oops, sorry. IPVGP soft clear IPv soft in. Let's see. Now we're receiving it. Show IPv6 routing table. Okay, I think that they should be able to ping each other. Oh, I should use my source, my own IP address. They will using the one IP address that is not being advertised. Okay, that's great. What if I do a trace? Oh. I want to trace this using this. So this is the IP address that belongs to router 2. This is the IP address that belongs to router 3. This is the IP address that belongs to router 4. And finally, it will land in router 5. So for this lab, remember, use these commands, show, run. This is how our configuration ends up. And remember, I didn't issue this command. This command is these commands are entered automatically. You can prevent that from happening using a CISCO command, but we are not using really IPv4. This was entered automatically, and this is the actual configuration that you need. You advertise your network, you create your you activate your neighbor, and you allow your own autonomous system within the prefixes that are advertised to you. So on router 3 is interesting also because remember to configure it as a route reflector. Okay. Let's do another ping, and let's do the opposites on this side. Great, that's it.